These are the notes on section 11.2. We're going to be talking about the area of parallelograms, triangles, and rhombuses. So first of all, in the figure up here on the left, if this is a parallelogram, remember a parallelogram is a quadrilateral with opposite sides parallel. And a parallelogram has a base, so I can choose that side to be the base. Any one of the four sides can be a base. And the height is then the distance between the two bases, the parallel sides here. So that perpendicular distance would be considered the height. Okay? In the second figure up here, the triangle, I'm going to call this side the base. The height then is the perpendicular distance from the vertex to that base. So that becomes the height. And the reason for the third triangle here is I wanted to remind you that a height could actually be outside of the triangle. If this is the base, then the height goes from the vertex up here perpendicular to that base, perpendicular to that opposite side. So I have to extend the base out to the left and draw that height outside the triangle. You'll see that come up in a couple of minutes. Okay, so there are three theorems in this section. The first one is theorem 11.2. Says that the area of a parallelogram is the product of the base and its height. So if this is the base down here, and I draw a height right here, then I'm going to kind of derive visually the area of this parallelogram. And so what I want you to think about is if this parallelogram, green shaded region, were like a piece of paper, and I could take some scissors and cut off along this height right here, all right? And then actually pick that triangle up. So I'm going to erase it. And if I could pick it up and move it over to the right-hand side of the parallelogram. So I'm going to bring it over here, and I'm picking that piece of material up and putting it over here. And now if you think about it, what's formed here is actually a rectangle. Okay, so I'll just quickly shade this in. And you learned in the last section that the area of a rectangle is equal to base times height. So the area of this parallelogram really is just a rectangle. So therefore the area of the parallelogram is equal to base times height. Box the formula, and you need to remember that. So the area of a parallelogram is really the same as the area of a rectangle. Area is equal to base times height. Okay. So theorem 11.3, we're going to talk about the area of a triangle. And the theorem says the area of a triangle is half the product of the base and the height to that base. All right. Now the reason this is true, this is kind of common sense, is that if you think about it, a triangle is really 1/2 of a parallelogram. So as you can see in my figure here, the green shaded region is the triangle, is half as big as the parallelogram. So if this is the base, and remember the height I'm going to draw out here is here, then the area of the whole parallelogram is equal to base times height, but the green region is only 1/2 of that. So the area of the triangle is 1/2 of the base times the height. Okay? So there's another formula that you need to remember. The third theorem deals with a rhombus. The area of a rhombus is equal to half the product of its diagonals. So I've drawn a rhombus here. Now remember, a rhombus is a special parallelogram. It's a parallelogram where all four sides are congruent. So suppose that we say that the red diagonal is equal to D sub 1. We're using subscripts here. And the blue diagonal is equal to D sub 2. So the theorem then says that the area of the rhombus is 1/2 the product of the diagonals. So the formula would be 1/2 the product of D sub 1 times D sub 2. Okay? That is also provable. Proofs for all three of these theorems are actually in our textbook, and you could take a look at those when you get a chance. Okay, a couple of examples and then we'll finish this up. So suppose this shaded region that I have here is a parallelogram, and that angle happens to be 60 degrees, and the base is made up of two parts, of the 10 and then the 2. And the goal here is to find the area of that parallelogram. So first of all, you have to remember that in a 30, 60, 90 right triangle, if the side opposite the 30 is 2, then the side opposite the 60 is 2 times the square root of 3. So therefore, the height of that parallelogram is 2 times the square root of 3. And if I multiply the base times the height, remember area is equal to base times height, then the area is equal to, well, the whole base is 12, right? 10 plus 2 is 12. And when I multiply that times the 2 square root of 3, I end up with an area of 24 times the square root of 3. So there's a parallelogram that involves the 30, 60, 90 right triangle. You could also see parallelograms where we need to use SOHCAHTOA, trigonometry, to be able to find that height or perhaps the base. So remember trigonometry when you're going through the homework. All right, my last example here is another parallelogram. That shaded region represents the area inside a parallelogram. And we're given the top side is 9, the diagonal side on the right is 6, and that's a 45-degree angle. So if that's a 45-degree angle, then up here would also be a 45-degree angle. So we end up with a 45, 45, 90 right triangle. So remember our rule here is that if the hypotenuse is 6, then either one of these two sides, in particular I'm interested in this height here, is going to be 1/2 of that 6 times root 2. So the height would be 3 root 2. Okay? The rule was take half of the hypotenuse times root 2. And therefore, if the top side is 9, then the bottom side is 9. Remember, opposite sides of a parallelogram are congruent. So the area is equal to base times height. So in this case, it's going to be 9 times 3 root 2. And therefore, the area is equal to 27 root 2. Okay, so that's going to take care of the notes on this section. And I'm going to stop this video.